Okay, Algebra 2. Now let's take a look at horizontal and vertical shifts of exponential and log functions. Because, of course, the ones we looked at just a moment ago were very basic ones. Um, this is super basic. We're going to look at those. Those are a little bit more interesting. And, of course, if you remember from quadratic functions, absolute value functions, the h and k represent horizontal and vertical shifts of the parent function. So if you think about this as your parent function, all we are doing here is shifting that graph horizontally h units and vertically k units. Same thing here with the log form. We are shifting the log function h units horizontally and k units vertically. Okay, so note that in the exponential function, the value of k, which shifts the graph vertically, shifts the asymptote up or down. So this value determines the range of the function. Notice that neither the horizontal nor vertical shift affects the domain of the function. It is always all reals for exponential functions. So if we just take a look at this one example, y equals 2 to the x plus 3 power plus 5. We can see that this is a shift 3 units to the left, right? Because my h value would be negative 3, and 5 units up. So I have my horizontal asymptote here at y equals 5. It shifts the entire graph up 5 units. So now the range, rather than being the set of all positive real numbers, if you remember this, right? Here my range was just all positive reals, but now I've shifted that graph up 5 units, so my range is now greater than 5. And so you can see that the range of any exponential function can be defined by y is greater than k. So whatever your k value here, the range is going to be greater than that value. Okay. What does this mean for log functions? Notice that in the log function, it's the value of h that will shift the graph horizontally, and that will shift the asymptote left or right. Right, so we care more about that when we're thinking about where the asymptotes are. Here, we're worried about what the k value is, because that's going to shift your graph up or down. It will shift your asymptote up or down. Here we have a vertical asymptote, so we've got to think about which way it's shifting, right, left or right. So it's going to be the h value that will determine the domain of the function. Here, this determines the range. In log functions, it's the h value that will determine the domain. And notice that neither the horizontal nor vertical shift affects the range of the function. The range here is always all reals. So if you look at this example, y equals the log of the quantity x plus 4 plus 2, we will have a vertical asymptote at x equals negative 4, because of course this is my h value would be negative 4. So I'm shifting this basic function to the left 4 units. And of course the shift up 2 units is not as obvious, but it does shift the graph up 2 units. And so here you can see that the domain of any log function can be defined as x is greater than h, the range of real numbers. For exponential, domain is all real numbers. You can remember that by saying darn and rarn. All right, so next video, we're going to look at some sample log graphs to illustrate identifying the domain and range.